Welcome to the other section of VHDL programming. So today we are going to do the programming for multiplexer. Okay, we will do the basic multiplexer 8:1 and 4:1. Okay, as we start with the multiplexer 8:1, uh, the multiplexer 8:1 implies number of inputs are 8 and depends upon the switches, the select lines. Okay, 2 power n is number of n is number nothing but n is number of selection lines. N is selections line here, so total number of n is 3, so that means 2 power 3, so 8 inputs and 3 selection line and 1 output. So you can see here select 0, select 1, select 2. Okay, so when based upon this, the data line will be selection D0, D1, D2, D3, D4, D5, D6, D7. Okay, so let us start with the programming. So I have created the project mux8x1 here, add new source, so VHDL module. So we'll write the mux 8_1 next. And here previously we were giving the 1-bit input. Okay, in this case we have different type, like data. For data we have 7-bit 8-bit. For selection we have 3-bit. So how to give the data? So let us write D as an input, D as an input. Okay, so we'll click the bus here. So we'll start from 7 to 0. That means most significant bit is 7. So 7 means 7, 6, 5, 4, 3, 2, 1 and 0. So total is 8. So D stands for data bit here, and E stands for enable, which is sometime we are using or sometime we will not use, but again it is to enable the chip. Okay, and this is selection. For this case we have 8 inputs, so selection will be how much here? So 3-bit will be the for selection, so 2 down to 0, 2, 1 and 0, 3 bits. Okay, and Y is only one output, one bit output. Okay, next we'll finish this. So remove it. So here in this case, library IEEE use IEEE.std_logic entity mux8:1 port D and enable selection and Y and entity. Then start the architecture, begin. Okay, after begin we have to write the main structure of the program. Okay, architecture. So let us see the architecture. Begin, we'll write the process, enable selection line and D. These 3 are the inputs. Okay, we are processing these 3 inputs. Okay, then we'll write again begin. After our process you should start the begin. After begin we will write the main idea. Okay, so we are using enable here. Okay, so if enable is equals to 1, that means I have written the single bracket or single apostrophe. Okay, if it is 1, then Y is 0. Okay, that means output is anyhow it is 0. I will write else. So first case is enable equals to 1. Okay, or Y 0, that's it. Okay, next case, if enable equals to 0, then what? If enable is equals to 1, then this is the case. If enable is equals to 0, okay, it means it is automatically, if enable is equals to 1, then it is taking automatically Y or 0. Okay, otherwise the another condition is enable equals to 0, then we will write selection 0. Sorry, if selection case selection. Okay, selection, that means next thing, enable is equals to 1, this one is finished, and then selection. If selection is okay, That means if selection line is 3-bit, okay, selection line is 3-bit. If it is 0 0 0, that means y is d naught. D naught means data bit 0, it will be selected. Okay, same case will be for the selection when it is 1 1 1. So now it will be when it is 1. So let us put time here. Okay, so when it is 0 0 0, y implies 0 0 bit will be selected, 1 bit will be selected, data bit, okay, the data line 0 1 2 3 4 5 6 7. In this case I have not written. In this last case when it is 1 1 1, I have not written. That means other case. When it is other case, so other case is 1 1 1 only, so D implies 7. So now we have to end the things. Okay, so first what we have to end here, and the behavior, this, and we have to do, which is the last. Okay, then we begin with the process, and we have to do, and the case, and we have to do it. Okay, so first we will write and case, then we start with the if and if, then we start with the process, this process, and before okay, we end with this case is end here. Okay, and this case, then it is end. Okay, so it was not the keyword, so it was not showing the blue color. When I turned it, the keyword turned to the blue. Okay, so end case, and if, then and this is process. Okay, then and behavior. This is my 8:1 multiplexer. Let us save it, then see the synthesize this. You will get a synthesis report. Okay, and this is going to create a schematic. This is our multiplexer. Okay, so this is the selection line. You can see the selection line here. Let me zoom in. So this is selection line from 0 to 2, data is from 0 to 7. Okay, then output result is 1 bit. Okay, based upon the enable. Okay, so save it, and we will go to the simulation process. Behavior syntax check. Okay, similar behavior module. Okay, so in this case we have the data of 0 to 7 bit. Okay, and enable, and then select 0 to 1, 2 to 0, and output 1. Okay, so let us give this as a data force constant. Okay, previously we were getting only one value here. Okay, now we have given it as a 7-bit input. Okay, so let us start with this one, 0 0 0 0 0 0 1. Okay, one more 0 to 7, it is 4, should be one more 0 here. Okay, so apply. Okay, so based upon this, so let us start with this. Okay, that means 0 0 0 1. Now let us make enable as 0. So enable as 0, apply. Okay, so output is 0. Okay, so now based upon this selection line, now this is your input data. Okay, 1 0 0 0 1. Now we will give the selection as force constant 0 0 0, apply. Okay, and which line will be selected here? the first line is selected. 001 means 001, the first line is selected. Let us give selection as 0 force constant. Let us make it as 001. Okay, so it is 0 here. Okay, so we have to change this to force constant 0 0 0 0 0 0 1 0. Apply. Okay. So let us check again. So now the output is 1. Okay, so you can do the many iteration like this. So we'll go to the force constant, we'll go to the 0 1 1, and again the output will be 0. Output will be 0. Okay, you can take multiple or you can stop here. Thank you very much for listening, and we will do the same way. Now we will start the new technique called the test bench. Okay, now we were giving the from the keyboard. Now in the test bench we will give the input from the system only. So we have to write the program for the the test bench also. Okay, we'll start with this.